Okay, Chapter 8, Day 1. What we're going to do is we're going to look at what are linear regression lines. Now, I know you've had some experience with linear regression models in the past. It's probably been a couple years. So we're going to take a little deeper look into linear regression models. All right? So, the letters we use are LSRL. That's another way to say linear regression model. It is the least squares regression line. All right, LSRL stands for least squares regression line. It is the linear line that best models the data. It's never going to be perfect. We just try to find the one that best fits the data that we have. It is a predicting equation. It's an equation that we use to make predictions based on data. We use it to predict outcomes for a given x variable or x outcomes for a given y variable. So the equation that we use looks like this. It looks like y hat equals a plus bx. Now, I know you've seen a plus bx or mx plus b in the past, but what's new is we put a hat on top of the y. We call it y hat. And we put a hat on top of it because we're saying that this equation came from data that we took, and it's our predicting equation. Calculator commands, we use statcalc8 to get this equation. So all your data goes into list 1 and list 2, and then statcalc8 is what you use to get the equation. You might see it written like this if you're taking the AP exam. Y hat equals b sub 0 plus b sub 1 x. So either way you see it, they both have the same meanings, where this first part that stands alone is what we call the y-intercept. And this part that's next to the x variable is called the slope. So I think you probably remember words like slope and y-intercept in the past. So we always start out with a y-intercept and then plus or minus slope. That's the general format of that equation. Now, here's some things to know. This least squares regression line always goes through the point x bar, y bar. It'll always go through the average x and average y value. Some other things to note. This least squares regression line minimizes the square of the residuals. That's why it's called the least squares regression line or least squares residual line for a given set of data. Minimizes the square of the residual. In Algebra 1, you talked about residuals, but probably not a lot, so we're going to revisit those. So a residual is the vertical distance from a given point to the regression line. All right, so here's what I did. I took a set of data and I graphed it. So here's my scatter plot. Here's my regression line. Okay? Every single one of these points has a residual. It is the vertical distance from the data point to the regression line. So this right here is a residual. This is a residual. This is a residual. This is a residual. This is a residual. It's the distance. Now, if the points that are above the line, those will have a positive residual. Points below the line, they will have negative residuals. Pardon me 1 second. So points below the line have negative residuals. All right, but these residuals, the calculator calculates and it squares them and it adds them up, but basically it minimizes those sum of the squares. But what's important to know is that a residual is this vertical distance, and points below the line have negative residuals, points above the line have positive residuals. The formula for the residual is as follows. The formula for the residual is the actual y value of the data minus the predicted y value when the x value of the data is substituted into the equation. That is how you find out the residual. So for example, let's say I wanted the residual for this data point. All right, if I draw a vertical line, it hits the least squares regression line right here. So this line has the formula y hat equals a plus bx. This point has coordinates x, comma y. Up here, the x coordinate is still x, but the y coordinate would be whatever you get after you plug x in and get out a y hat value. The residual is the difference between this y hat value and this y value. So the residual is the y value from the data minus what you get after you plug x in. Now, if I were to add all of these positive and negative residuals up, the sum of the residuals is always 0, something also good to know. So let's look at it in action. So here's a set of data that I had from last year in which we took a forearm from people, so the distance from your elbow to your wrist, and we took their height. Okay? We measured forearm and we measured height, and we looked at the relationship between forearm and height, and this was our equation. I actually plotted forearm on the x and height on the y. And I got an equation, 130.67 plus 1.6x. After I put all the data into the calculator and did stat calc 8. So, I can write this in words. Height hat, which is my predicted height, is 130.67 plus 1.6, whatever my times whatever my forearm length is. So if I put in a measurement for my forearm, I can make a prediction for how tall that person is. So if someone walks in the door, I say, let me measure your forearm, boom, you're going to be this tall, and I can make a prediction about how tall they are. This is what the data looked like when we graphed it. All right, I had a regression line that went through the data. Here were my values, forearm and height. Now, I had a student in class, his name was Dylan, no relation to the Dylan I have this year. And I said, I want to find the residual for Dylan. So I asked Dylan, I said, Dylan, how big of forearms did you have? And he said, mine are 24 centimeters. How tall are you? He said, I'm 190 centimeters. Given this information, I want to know what was Dylan's residual. So, again, the residual formula is to take the y value from the data, Dylan's y value, minus the predicted y value when we take x, Dylan's x value, and plug it into the equation. So to get Dylan's residual, I need to take his x value and plug it in for the forearm, for x, and crank out an answer. I got 169. So predicted, he should be 169 centimeters tall. So our residual is the actual 190 minus the predicted 169. Dylan's residual was 20.93, positive. So if I look up here on this graph, he's one of these points that are above the line, positive. So if I had this scaled, I could come over to 24 and probably find his point. So what do we know? What does this tell us? Dylan is 20.93 centimeters taller because his residual was positive, taller than what we would predict for someone with 24 centimeter forearms. That's what the residual tells us. It tells us how much taller or shorter in this case. So this might be Dylan right here. And this distance then is 24, let's see what it said again, 20.93. So this would be 20.93, and this down here would be where 24 centimeters is on the X. So this could be Dylan right here. He is 20.93 centimeters taller in height than our line predicts for someone who has 24 centimeter forearms. So that's the introduction to regression and introduction to what a residual is and how we calculate it.